The AI revolution, it feels kind of limitless, right? It's all happening up in the cloud, just pure data. But what if the biggest thing holding it back isn't digital at all? What if it's something physical? Today, we're going to pull back the curtain on the massive hidden energy cost of AI. And trust me, it's pushing our world to a real breaking point. So let's dive in. Yeah, this quote just nails it, doesn't it? We've got this dream of infinite digital intelligence, but it's smacking right into a very real, very solid wall. And what's that wall made of? You guessed it, power. Pure, raw electricity. All right, so first things first, let's really try to get our heads around the sheer scale of AI's appetite for energy. And I'm not kidding. The numbers we're about to look at are absolutely mind-boggling. Okay, let's start with just one number, 1 gigawatt. Just let that sink in for a second. I mean, it sounds huge, right? But what does 1 gigawatt actually mean in the real world? Well, that single gigawatt, that's the power needed for just one new AI data center. And to really put that into perspective for you, that's the same amount of power churned out by a dedicated nuclear reactor. But here's the kicker. 5 of these monster data centers are coming online in the US this year alone. 5. And look, this isn't just a US thing, not by a long shot. Let's hop over to the UK. This chart shows the backlog, basically the waiting list, for new connections to the power grid. It's set to explode by an incredible 460%. And guess what's driving that surge? Yep, data centers. The existing infrastructure it can't handle it.
So that brings us to the next big piece of the puzzle. See, it's not just about how much power AI needs, it's about the kind of power. Let's get into why our current energy systems are really struggling to keep up with this very specific, very new kind of demand.
Okay, the heart of the problem is something called the intermittency trap. Here's the deal. AI needs power that is totally constant, unwavering. Think of it like a faucet turned on full blast, 24/7. That's called baseload power. But our big renewables, solar and wind, well, they're intermittent, right? The sun isn't always shining, the wind isn't always blowing. So you have this fundamental mismatch between what AI needs and what our greenest power sources can reliably provide. Now, don't get me wrong, the big tech companies, they know this is a problem. You've got Microsoft making huge bets, like a $6.2 times billion-dollar investment in Norway to run their computing on 100% renewables. And we're even seeing these cool green AI companies pop up that, get this, use AI to help make the grid more efficient. It's kind of ironic, right? But here's the thing. Even with all these smart moves, that fundamental need for steady, constant baseload power, that hurdle is still there. So, if the grid we have now can't handle it, and even our best renewables have this intermittency issue, where do we turn? Well, this is where the story takes a really interesting turn. We're seeing a surprising, and for a lot of people, pretty controversial, solution making a major comeback. And that solution is the Small Modular Reactor, or SMR for short. Now, when you hear nuclear, you probably picture those gigantic, sprawling plants. But that's not what these are. Think smaller. Think factory-built. They're designed to be put together on site. And this isn't just some far-off sci-fi concept. The EU is already throwing 200 million euros at this to get them deployed faster. That's a huge signal that a big strategic shift is happening. So why are SMRs suddenly so attractive for AI? Well, first, being factory-built means they're cheaper and faster to construct. Second, they're scalable. You can add more modules as your data center grows. But the real game changer, the absolute key, is this idea of behind-the-meter power. That means the SMR plugs directly into the data center. It basically lets these tech giants become their own private power companies, completely off the public grid. And why are they considering such a radical step? It all comes down to projections like this. The growth is just exponential. By 2030, which is right around the corner, AI could be responsible for half of everything happening in all the data centers, everywhere. The sheer scale is just too massive to solve with conventional thinking. But, a purely technical solution like this brings us to our final and maybe the most important part of this whole story. Because this isn't just about plugging in new reactors. This forces us to make a really profound choice about our priorities as a society. It's something people are starting to call the humanity paradox. And to really understand the choice we're facing, just look at this number. By 2030, Data centers are projected to guzzle down a mind-blowing 945 terawatt hours of electricity. That's a staggering amount. And as you can see from the chart, AI is on track to claim nearly half of that entire pie. This puts a very real and honestly a very difficult question in front of all of us. When the demand for electricity just skyrockets like this, societies and governments are gonna have to choose. What do we prioritize? Do we funnel that power into training the next incredible medical AI that could save lives? Or do we use it to heat our homes in the winter? It's a tough one.
And that brings us to this final thought, which I think just perfectly sums up this new reality we're walking into. For years, we've all heard the phrase, data is the new oil. But what we're starting to realize is that the most valuable asset in the near future, it isn't the data. It's the raw physical power that actually brings that data to life.
Okay, today we're going to peel back the digital curtain on artificial intelligence. We're going to look at the one thing, the one resource that could literally stop it dead in its tracks: power. We're diving into the massive and honestly often hidden energy demand that AI is creating right now.
So, when you think about what really fuels AI, what comes to mind? Probably complex code, brilliant algorithms, that sort of thing, right? Well, what if I told you the real engine behind this whole revolution isn't just software? It's something much more physical.
The reality is AI runs on an absolutely colossal physical infrastructure. I mean, we're talking about these sprawling, city-sized data centers, miles and miles of high-voltage cables, and a power grid that, let's be honest, is already feeling the strain. It's a world of copper and turbines. To really get a sense of the scale of this challenge, just look at this number: 460%. That is the projected backlog on the UK's energy grid by 2026. This isn't some far-off, distant problem, you know? This shows you just how wildly unprepared our current systems are for what's coming. And this brings us right to the heart of our explainer today: AI's unseen power crisis. This is the critical energy bottleneck that could seriously define the next decade of tech progress. It's a big deal. So here's the bottom line. The explosive exponential growth of AI is creating an energy demand that our existing infrastructure it wasn't built for it. It's that simple. Today's overstressed grid can't handle the sheer amount of power that tomorrow's intelligent systems are going to need. But you know, where there's a crisis, there's always innovation. So the big question is, how does the market bridge this enormous gap? Let's get into the immediate two-part solution that's already being rolled out to build that energy bridge. Okay, so the strategy is basically hitting this from two angles at once. On the one hand, you've got grid resilience. This is all about the heavy-duty stuff, building those high-voltage superhighways to move massive amounts of power from where it's made to where it's needed. Then, on the other hand, you have the efficiency play. This is a bit more subtle. It's about using AI itself to manage its own power consumption way more intelligently.
And look, this isn't just theory. Companies are already doing this. You have players like Quanta Services who are landing these record-breaking contracts to build out that high-voltage infrastructure. And at the exact same time, you've got companies like STEM, whose Athena AI platform is helping data centers coordinate these huge battery storage systems. It lets them draw and discharge power in a much smarter, much more efficient way.
This quote, it just perfectly captures the strategic shift that's happening. It's that classic gold rush analogy, right? The real long-term opportunity might not be in just training the next flashy AI model, but in building the essential infrastructure, the picks and shovels that the entire industry completely depends on. Now, that two-pronged approach is the bridge. It gets us through the immediate problem. But what's the final destination? Let's look a little further down the road to the long-term, more permanent solution that's really starting to take shape: dedicated nuclear power for AI. This roadmap here gives us a really clear picture of the next few years. So, between 2026 and 2027, the focus is all in on modernizing the grid, building those power lines and battery systems we just talked about. But then, look what happens from 2028 to 2030. That's when we see the big shift. Small modular reactors, or SMRs, are projected to become the standard power source for new, dedicated data centers. So, what does all of this mean when you put it all together? It means we're not really talking about tech and energy as separate sectors anymore. Not at all. We are watching, in real time, the birth of a new, totally unified ecosystem. And this, right here, is the key takeaway concept: the AI Energy Nexus. It's this simple but profound recognition that big tech and big energy are becoming fundamentally intertwined. You literally can't have one without the other anymore. The future success of AI is now directly tied to the resilience and innovation of our energy infrastructure.
And I think this quote just sums it all up beautifully. It's a really powerful reminder that our increasingly digital, intelligent future is completely 100% dependent on the very physical, very tangible world of energy. You know, the cloud isn't some ethereal thing. It runs on coal and gas and more on nuclear power.
Which leaves us with this final, crucial question to think about. As our digital ambitions soar higher and higher, are they fundamentally chained to the limitations of our physical world? Is the power grid the ultimate gatekeeper of the entire AI revolution? The answer to that is going to define the next chapter of technology. Thanks for tuning in.